Okay. There we go.
Hello, welcome to our final research proposal. I'm Nate Fleischli. I'm here with my teammates Riley and Daniel, and today we want to talk about fairness in automated strike zones in the sport of baseball. We've seen a couple automated zones already implemented in other sports. Today we want to focus on baseball, a sport that's yet to have it. So for today, we want to talk about our introduction, some model definitions, related works, and next steps. So for some inspiration, we wanted to give you the point of view of an umpire in sport. This is Stanford baseball. I'm on the team when we played in the College World Series, and this is at various speeds of baseballs, but you can see it cross the plate very quickly. A 90 to 100 mile an hour fastball crosses the plate in roughly 400 milliseconds, which is roughly a blink of an eye.
Yeah, so automated strike zones, which are being introduced in the minor league, are basically a 2D strike zone. And in order, if the ball, when it's pitched, enters that strike zone, it is considered a strike, else it's considered a ball. And so we see with umpires, when they call strikes, they're not exactly perfect. As you can see, the batter on the left is quite short. His name's Jose Altuve. He's 5'6", and umpires are less likely to call high strikes on him. The middle nine boxes are the strike zone, and the upper three mean the fact that they're low mean that they're less likely to call strikes. Conversely, Aaron Judge, who's quite tall, is less likely to have low strikes called on him. Next slide, please. Next slide, please. So because of this, we're having a mathematical model to model what a pitch is to see these automated strike zones, how fair they are across player heights. So we're basically abstracting every baseball pitch to three inputs: the height of the batter, the distance of the ball from the center of the plate horizontally when it crosses the plate, and the distance of the ball from home plate, from the ground when it crosses the plate. Next slide, please. And so with these pitches abstracted, we can basically compare how accurate automated strike zones are compared to a collection of umpires. So we propose that a strike zone, automated strike zone, is only fair if it meets two thresholds. One is equalized odds of strike and ball calls across player heights. So this basically says that if a group of umpires, if 80% of them thinks it's a strike, then the automated strike zone should call that pitch a strike the same percentage if it is a small batter, a medium batter, or a high batter, so that it doesn't change based on player height and unfairly disadvantage certain players. And then secondly, we believe that a automated zone has to be accurate. So how are we really measuring accuracy? We're comparing how an automated zone does to its alternative, which is a single umpire. So if we consider a group of umpires as like the ground truth, we want to see that for pitches, for a number of pitches, that in general the automated strike zone is closer in calling strikes and balls to the expected value, the group of umpire value, than the single umpire value. And if it satisfies both of these, we consider it a fair automated strike zone. Thank you. Next slide, please.
Okay, so for our related work, next slide, we looked into a paper called Fairness Indicators for Systematic Assessments of Visual Feature Extractors. So a little bit long, but the paper argues that a systematic diagnosis of fairness, harms, and biases of computer vision systems is really important, and it's an important step for building responsible systems. And so in order to sort of solve that, the authors proposed 3 fairness indicators, and those focus on harmful label associations, which basically measures the extent to which classification algorithms create harmful or biased label associations. The second one is disparity in learned representations of social and demographic traits. And so this is just looking at the effectiveness of a visual system and recognizing and distinguishing attributes of images. And then the third one is biased performance on geographical diverse images. So this is just assessing the object recognition accuracy of visual systems. Next slide, please. So how does this relate to our project? Well, while we don't have to use the exact same fairness indicators that the research paper talked about, we can use similar indicators in order to evaluate the performance of the strike zone system. And so this is needed in order to really assess the fairness because of the different player demographics, whether that be different player heights or different stances in the way that people hold their bat and hit the ball. And then secondly, the paper really stresses the importance of continuously evaluating models So we should use this by constantly analyzing our model for its accuracy and seeing if our fairness definition really makes sense and if we need to adjust it.
Great. And so I will talk about next steps for our project. Currently, the limitations of our model and setup is first defining a pitch. As you can imagine, an automated zone currently implemented is a 2D plane at the front of the plate. So you can imagine a world in which a pitch crosses the same XY coordinate on this plane, but has two different movement directions. One of which, if it's extremely downward in the negative direction, can bounce on the plate. In practice, a human umpire would not call that pitch a strike, compared to one that is more straight and linear through the plate. Secondly, umpires do have biases, as we saw. These biases are baked into our collection of umpires, model F. So we should consider this as a limitation in our model setup. Lastly, there's an instance in which the batter likes to squat down and shrink the distance between his waist and his knees. Umpires are susceptible to making that the new zone, as it's really hard to project what the true batter's height is. Our model does not do that. Instead, keeps the main batter's height, but this will be baked into the model. Lastly, moving forward, we need to, as we were talking about defining a pitch in terms of other than XY coordinates, we need to take in more information to really define what a pitch is. We need to clean the data from historical umpire biases, and we need to adjust our threshold of 0.7 to figure out what's the correct threshold for this model setup. Thank you for your time. As you can imagine, calling balls and strikes is extremely hard for umpires, so we'd love to help the MLB implement such fairness in the sport as we go forward. Thank you so much.